We can examine this behavior in terms of the components. You see that the magnitude of the field is about 2.3 e to the minus 6 Tesla at the maximum here. If we look at the real part is very much the same, but this one flux line skims even a little closer to the surface. If we look at the imaginary part, we see a much reduced magnitude and flux lines that travel much further into the plate. And in fact, in the imaginary component, you can see closed lines of flux not around the coil, but around the eddy currents that exist in the plate. We can examine the eddy current effect in more detail by zooming in on the plate and then setting the display here to demonstrate the induced J field. We'll look at the magnitude of the J field and plot it in the specific region since there is no current flowing in the empty space. Here you can see lines of equal J density. We can also display this as a gradient color plot in order to see the current at different depths into the plate, and we can display the induced current again in either magnitude, imaginary or real parts, depending on what is of most interest. Finally, it's also possible for the materials to put in a material which is both conducting and permeable. So here we have a steel which has a permeability of 1,000 and a conductivity of 1 e to the 6th, about 10 times lower than the conductivity of the copper. If we assign this to the plate and solve one more time, now we will still be able to detect eddy currents in the plate. However, they will be concentrated much closer to the surface than with the copper because the skin effect will be much smaller at the same frequency due to the permeability of the steel. If we go back and look at a field line plot, we now see a combination of the effects observed in the conductive and the permeable materials. The flux is not completely expelled away from the plate like it was with the pure conductor, but neither does it penetrate as far into the plate as it did with the non-conductive steel. Rather, it enters the plate and then skims along the very surface of the plate due to the skin effect. Other features of OERSTED, which will be demonstrated in later videos, have to do with the ability to set up transient problems, to set up coils and windings, and specifically to set up windings which involve the skin effect within the winding itself for solid conductive coils.